I hope everybody's had a chance to try it. It shouldn't be that difficult if we followed Teacher Jen's steps exactly. So as I could tell, Teacher Jen would always draw a line segment, right? And we know that we've got 2 endpoints for our line segment over here. And they tell us that the point 1, 1 lies at the center. So we know that the coordinate 1 and 1 is the center point. And then one of the endpoints over here is -4 and 7. And the other endpoint on the other side is called Q and -5, right? Now they want us to find the value of Q. And we can see here that Q is our X value. And 1, 1 is the midpoint. So we know we need to use the midpoint theorem to do this. But we're only looking for the X value. So we're only going to calculate the midpoint of the X value. So we know in this case, we would say Q plus 1 divided by 2 must equal to, I'm lying, Q plus -4. Hello, Molebogeng. Q plus -4 divided by 2 should give us 1. All right, and then we're just going to work our way backwards in that sense. So I know I've got Q minus 4 over 2 is equal to 1. To get rid of this divide by 2, I'm going to multiply by 2 on both sides. Multiply by 2 times 2. And then those 2 will cancel out. So I will have Q minus 4 is equal to 2. And now I want to solve for Q. So -4 will go over to the other side and become +4. Therefore, the X value, Q, is equal to 2 plus 4 is 6. So this endpoint over here is 6 and -5. Those are our 2 endpoints there. Hello, Rikanyo. All right. So that's the last thing that you guys learned with Teacher Jen last week, Wednesday. And today we're going to keep going. But today's lesson is kind of nice because it's on something that you've probably already done before. But we're going to have to try and squeeze a lot of stuff in. So I hope you guys is going to stay with me as we go along today. All right, let's start with the gradient formula. Apart from analytical geometry, where else have we seen the gradient? Who can tell me? Where else have we seen a gradient before? Anybody? I'll tell you specifically, you learned about it for the first time in grade 9. It came with a particular something on a Cartesian plane as well. Does anybody remember? Yes, Oko, it's graphs, right? It's the equation of a straight line. Normally, we know that the equation of a straight line would read y is equal to mx plus c. And that m that we're looking at over there, that m, this m, is our gradient. It's the exact same gradient, guys. Doesn't change at all. It's the gradient that we're calculating for. And we know that the gradient is known as the change in the y values over the change in the x values. Okay, normally we would replace this gradient part over here with the big M. Right, so if you're taking notes, M is equal to y2 minus y1 over x2 minus x1. And we're going to number them the same way that ma'am does when she does any of the others. All right, I just need to double check. Give me a thumbs up if you've done the gradient formula at school for analytical geometry. Yes, thumbs up, no thumbs down. So I know how slow to go. Can you guys let me know? Okay, Oko says yes. Kanyo also says yes, lovely. In paper 2, yes. Yes, correct. It is part of paper 2. It is, Desmarie, it is. So yes, we'll be able to have a look at it. All right, Mandisa and Abulele have not. All right, that's okay. So yes, Mandisa.
Ma'am, I just wanted to say that with all the geometry that you guys are doing now, we only started in term 3, not in term 2.
You only started it in?
We're only gonna start it in term 3, because paper 1 for this term is algebra and functions, then paper 2 is trigonometry.
Oh my goodness. Okay, so I think, you know, because every school can kind of sort of do their own thing, as long as we get to the same point at the same time, Do you go to an IAB school?
Yes, ma'am.
Because that's what's happened. Ah, that's why. Okay, because IAB schools kind of make their own rules until they get to the matric exam, much like us. So at the moment, once I finish analytical geometry, I'm going to jump into functions. Okay, so that's still something we're going to be able to get to the end of before you write your exams. I don't know when your maths exam is.
It's on Friday.
On Friday, oh my goodness. Sure, my darling. Okay, my best advice is for you to go watch the lessons I did on functions last year. They're on our YouTube channel. Okay, because I'm only going to delve into functions starting next week, Monday. So that's going to be a bit problematic. Okay, sorry, my darling. It's just I'm following the government schedule exactly, and that's the problem. Like my kids at the school that I work at as well, we're also IEB, and we do grade 11 trigonometry in grade 10. So it's a little up in arms, especially if you go to an IAB school, because they kind of make their own rules. But we will get to it, I promise. Okay, we're going to get to everything. So for now, everything that we're doing will seem like revision to you because you're going to do it in class and you would have already done it. Okay, then when we start functions, that'll be your revision. In a sense, because you would have already written about it. But please check out the YouTube channel. Okay, I did it in a lot of detail last year.
Okay, thank you.
Sure, I kind of knew our timetables wouldn't 100% match, but I didn't think they'd be this different. Sure. Okay, all right. For those of you who haven't seen this before, I'm going to try and go a little slow so that we can keep up. But it's quite simple. Because we are looking at a gradient of two lines, we know that the gradient is actually the same thing as a slope, right? So we know that a slope actually tells us about how steep a line actually is, right? Let's think of the analogy of a bicycle. Let's say, for instance, you're riding a bicycle, right? If you're riding along a straight line, right? If you're just riding along a straight line, you're using the exact amount of energy that you would need to use, right? It's not too much, it's not too little. You're just driving you're just riding your bicycle on a straight line, right? No issues. So let's say, for instance, now you come up a hill. If I start going up the hill, am I going to use more energy or less energy? More or less? Of course, Balisa. It's a fairly easy question. I'm going to use more energy. So whenever I see that my gradient or the steepness of my graph goes in this direction, I'm going to think that this is a positive graph because I have to use more energy. Right? More energy. There's more energy. Now, if I'm moving straight like that, I'm not using more energy. I'm not using less energy, right? So when I'm over here, my energy or the amount of energy I'm using is not fluctuating. So the energy over here will be at exactly zero. Okay, along a straight like this, it will be exactly zero because I'm not using too much, I'm not using too little energy. Now, if I start going downhill, is that more or less energy? It's definitely going to be less, right? So going this way, I'm going to then use less energy, right? Less energy. And I'm using kind of a weird analogy, but it actually works in order for us to understand exactly what's happening. Now, if we look at any graph on our line, we're going to think of the amount of energy we're using as our gradient. Now, if our graph extends in this direction, that means we're using more energy, which means my gradient on my line needs to come out positive. Okay. If I'm moving on the straight x-axis like this, I'm not using any more energy or any less energy. Therefore, my gradient for a horizontal straight line is going to be exactly zero. So my gradient will be zero. Now, if I've got a negative slope, a graph growing like this, then my gradient will need to be negative. All right, because basically I'm just letting the bike do all the work. I'm going downhill. I don't need to do anything, and then we can level out, and therefore my gradient will be zero again. All right, thumbs up. Does everybody understand how we can see positive gradients, zero gradients or horizontal gradients, negative gradients? Are we all okay with that idea? We all good? Lovely. All right. So we're going to then look at this in that sense when we're looking at gradients today. So now if we look at this gradient over here, do we notice our graph is going up, right? It's heading up. We're definitely going to use more energy. So should my gradient be positive or negative? It should be positive, correct. Thank you, Vanessa. Lovely. Our gradient is going to be positive. We know that. So how do we use the gradient formula then? We're just going to do exactly what we did in the first one. I'm going to name this part over here x2 and y2, and I'm going to name the coordinates for a, x1, and y1. Then for us to calculate the gradient, we're just going to use it the exact way I've got it up here. y2 minus y1 over x2 minus x1. So we're going to go y2, which is 11, minus y1, which is 5, over x2, which is 4, minus 1. 11 minus 5 will give us 6 at the top. 6 divided by 4 minus 1 will give us 3. And therefore, our gradient for this line is 2. All right, let's try B. B is going to give us the exact same thing, right? We just need to choose which one of these to label. I'm going to label this one x1 and y1, and this one over here x2, y2. And remember grade 10s, if you name this x1, you cannot now decide that this over here is going to be y2. No, it doesn't work that way. If you name one of them x1, the corresponding y value needs to be y1. So you can't decide you're going to switch them up. Okay, I had one of my grade 9s last year do this. They decided that this was x1 and x2. No, that's not correct. Okay, we don't decide that. The x and the y values always go together. So you need to make sure if one of them is named x1, the corresponding y value is named y1. Same over here. If this is x2, the corresponding y value must be, or the corresponding value must be y2. Right, so to calculate the gradient, we're going to take y2, which is 8, minus 0 over x2, which is 6, minus x1, which is 4. All right, 8 minus 0 will give us 8. 6 minus 4 will give us 2, and 8 divided by 2 should give us a gradient of 4. And again, we can see, because our graph is going up, that it should give us a positive answer. All right, are we all okay with how to calculate gradient? Can I give you guys a chance to try some of these yourselves? They're quite nice and easy, especially when we've got 2 points. It's not that difficult at all. But if you know anything about Teacher Coco, we're going to do something a little bit more difficult as we go. All right, I'm going to give you a chance, guys, to do question A, B, and C. Pop your favorite emoji in the chat when you are ready. This should be nice and easy. I've just given you 2 points for you to compare to. All right, pop your favorite emoji in the chat when you're ready. Sure, you guys are super fast. Okay. I was thinking I'd have to give you guys a little bit more time. Let's give everybody else a chance to catch up with the rest of you. We'll get started in the next minute or two. All right, peeps, that's time. Let's have a look at some of these. Not difficult at all, hey? Easy stuff. So we're just going to go. Okay, let's start with A. We know the formula for the gradient tells me I've got y2 minus y1 over x2 minus x1. Right, so I'm going to name this x1 and y1, and I'm going to name this one x2 and y2. And then I'm just going to substitute. M is equal to 10 minus 4 over 3 minus 1. 10 minus 4 is equal to 6 over 3 minus 1 is 2, and therefore that is equal to 3. That's A. Let's look at B, the gradient for B. I'm going to name this x1 and y1, and I'm going to name this x2 and y2. This should give me 12 minus 0 over 3 minus 0. That's the same as 12 divided by 3. My gradient for B should be 4. Right, C. Again, we're going to name this x1, y1, and we're going to name this x2 and y2. All right, and we're just going to substitute 14 minus negative 2. So be very careful that you didn't write 14 minus 2, because minus negative 2 will give us a positive over here in between the two of them, divided by 9 minus 5. Okay, 14 minus negative 2 will give us 14 plus 2. That's going to give us 16 divided by 9 minus 5 is 4. And therefore, the answer we should get for C is 4. Let me know how we did. How much did we get out of 3? 1, 2, 3. How did we do? Did we all do okay? 3, lovely. Okay, excellent stuff, guys. Cool beans. All right. Now, if we've learned anything about Teacher Coco, that's not where we're gonna pause. Yes. Shall we try some challenges? Because clearly you're all getting 3 out of 3. You're all getting 100%. Let's try something a little bit more challenging. Okay. We're going to come back to question 2 in just a little bit. I want us to start at question 3. Okay, we'll come back here. We'll come back to question 2. That's the difficult one that we're going to be looking at. Let's all look at question 3 here. Now, they're telling us here that the line passing through 5 and negative 2 and 8 and C has a gradient of 3. Right. So if we're looking for an answer, we're going to then use the same formula for the gradient that we would, and we're going to say that the gradient, the answer that we would get for our gradient is 3. That's what we would get as an answer. We would get 3. So we then have to go, the gradient is equal to, this is x1 and y1, and this is x2 and y2. Now, I'm going to replace the gradient with 3 because they've told me that the gradient is 3. So I'm just going to go 3 equals y2, which is c minus y1 minus -2 divided by x2, which is 8 minus 5. All right, so now I've got 3 is equal to c plus 2 over 3. Okay, what would my next step be, grade 10s? What would I do next? I'm solving for c, clearly, yes, because that's the missing value. My next step, I'm going to put this over 1 and do what? Correct. I would cross multiply the 3. I would multiply by 3 on both sides. So you can either do that times 3, or you could just cross multiply like that. Okay, both of those methods would work. All right, I'll stick to this one. On this side, I'm going to get 3 times 3. That's going to give me 9 is equal to c plus 2, because 3 divided by 3 will cancel those 2 out. Then I just need to solve for c. I'm going to take the positive 2 over to the other side, and it's going to become -2. So c is equal to 9 minus 2, which will give us 7. Okay, so I'm not doing anything revolutionary here, right? Can you just pop in the chat for me if you'd like to try one of these questions alone, or if you still need help? So type help if you still want me to help, or type alone if you'd like to try one alone. Okay, I'm going to assume that most of us want to try this alone because it's quite nice and easy, right? It's quite nice and easy. Okay, let's try question 4 and question 5. And yeah, why not? Let's throw question 6 into the mix as well. Let's see who can figure out question 6. All right, pop your favorite emoji in the chat when you're ready. And then we're going to step it up from here in just a little bit. All right, we've got about 5 minutes, folks. All right, go for it. Oh, and if you finish before 5 minutes, try question 2. Try question 2. Guys, unfortunately, that's time. And I can't spend any more time on this. I think Mandisa got hers just in time. All right, because we still do have something else to discuss today. All right, so I'm going to get started on question 4. Somebody's asking a question quickly. For question 3, what happened to the denominator? 8 and minus 5. In question 3. Oh, so 8 minus 5 gave us 3. That's why ma'am had a 3 down here. Okay. 8 minus 5 is just 3. I hope that answers the question. Okay, lovely. All right, let's talk about question 4 quickly. Again, guys, we're going to use the gradient formula. And now we've been told that our gradient is equal to 4. So we're going to make the whole thing equal to 4. So for question 4, I'm going to name them x1, y1, and x2, y2. And then I'm just going to say the gradient, which is 4, is equal to y2, which is h minus negative 9, over x2, which is negative 2 minus negative 8. Right? So 4 is equal to h plus 9 over negative 2 plus 8 will give us positive 6. All right, and to get rid of the denominator, I'm going to multiply by 6 on both sides. So those two will cancel. So I will end up with 24 is equal to h plus 9. That means I'm going to take the 9 over and it will become minus 9. Therefore, h is equal to 24 minus 9 is 15. All right, let's look at question 5. Okay, the line crossing through 3 and negative 4, and m and 10 has a gradient of 2. Find m. All right, so if the gradient is 2, we're going to start by saying 2 is equal to y2, which is 10 minus negative 4, over x2, which is m minus 3. Right, so I'm going to get 2 is equal to 10 minus negative, that will give us positive 4, so that's 14 over m minus 3. Now this one is a little bit trickier because I need to then take m minus 3 out of the denominator. I need to multiply by m minus 3, but I'm going to put it in brackets because if I multiply this side over here by m minus 3, both of these things on this side need to be multiplied by 2. So we would need to distribute. So I would end up with 2 times m, that would give me 2m minus 6 is equal to 14. And then I would move the negative 6 over and it would become positive 6. So I'll end up with 2m is equal to 14 plus 6 is 20. Therefore, m is equal to 10. All right, so be very careful with that one there, guys. Okay, let's talk about number 6, because question 6 is a bit tricky, right? Now, I want us to quickly talk about the idea of having a negative fraction. Okay, let's quickly just delve into the idea of a negative fraction. If I told you guys that I've got negative 5 over 6, right? That tells me that my fraction overall is negative. But where does the negative belong? Does it belong on the numerator or in the denominator? What do we think, guys? What do we think? Where does the negative go? Does it go on the top or does it go on the bottom of our fraction? Oko, what do we think? Oh, sorry, my darling, I muted you by mistake. You can chat.
It's fine. It can be anywhere, right?
Correct, absolutely. Do we know why it can be anywhere?
I'm not sure.
Okay, all right. Can I explain? Because what you've said is 100% correct. Okay, good stuff, Oko. Well done. All right, let's think about this, guys. Let's think about this. If I wanted to divide 2 numbers and I wanted the answer to the 2 numbers that I divide to be negative, what kind of number would I need at the top and at the bottom for this to happen? Let's think about this. If I decide that the top is positive, then what does the bottom need to be in order for my answer to be negative? It would have to be negative. Yes, correct. It would have to be negative, right? Now, if I decided that the top was going to be negative, and I wanted my answer to come out negative, I know that the bottom would then have to be positive. Agreed? So if we are talking about a negative fraction, when we are distributing the negative or the positive, it doesn't really matter which one of them is negative in this case, as long as one of them is positive and the other is negative. They can't both be negative, because what's going to happen if I make both of them negative, a negative divided by negative will give us a positive and not a negative anymore. So when Oko says it doesn't really matter, it just means that either the top one has to be negative, but if the top one is negative, the bottom one needs to be positive, or if the top one is positive, the bottom one needs to be negative. All right, so you can choose which one of those is going to be positive and which is going to be negative. But in order for us to maintain the fact that the whole fraction is negative, we must have opposing signs on either of those. All right, is everybody with me there? Okay, and the reason I'm doing this is because of how we need to answer question 6. All right, so if we look at question 6, they've given us the line passing through 2 points, and they've given us that the gradient is -1/2. So I know that I've got -1/2 is equal to, and then I'm going to name this x1 and y1, and x2 and y2. Now, because this fraction is negative, it won't matter whether I make the 1 negative or whether I make the 2 negative, as long as one of them is negative and one of them is positive. So in this case, it doesn't matter. I'm going to make the 1 negative. It won't make a difference. I'll make it -1 divided by +2, and that will still give me -1/2. Okay, then I'm going to get y2, which is n minus 5, y1 over x2, which is 2 minus -2. All right, so now I've got -1/2 is equal to n minus 5 over 2, negative and negative will give me a positive, over 4. Right, now in this case, I will have to cross multiply because I've got a fraction on both sides. So I'm going to cross multiply that way and cross multiply this that way. So I've got 4 times -1, that'll give me -4 on this side, is equal to, then over here, I'm going to get 2 multiplied by n minus 5. And then we're just going to have to distribute. All right, so I will get -4 is equal to 2n minus 10. The -10 will go over and become +10. So I'm going to get -4 plus 10 will give me +6 is equal to 2n. Divide both sides by 2. Therefore, n is equal to 3. All right. So my answer is n is equal to 3. 1, 2, 3. How did we do? Did you manage to get 3 out of 3 for these questions? For questions 4, 5, and 6. How did we do? 3 out of 3 still? The radio silence is killing me a little. I'm gonna guess everybody's like, ish ma'am. Okay, 2 out of 3. Well done, Sally, for getting 3. Well done, Saneli. So it does get quite tricky. But again, it is algebra, guys. So the better we are at algebra, it's like 3 out of 3 on the first 2, ma'am. I don't know about the last one. That's fine. Okay, so remember, guys, everything that we're doing, even though we're adding things on top, it's still technically algebra. So the better we are at algebra as a whole, the easier mathematics becomes across the board. Okay, Alyssa, let's chat a little bit after this because I do need to do something else quickly. And then I'll just see, because remember, doing the right method is also very important. So we could say absolutely anything is equal to 3. We need to make sure we've done the correct thing. Okay, but we'll chat after this. All right, let's move on to something a little bit more substantive, right? We're going to talk about the gradient of parallel and perpendicular lines. Okay, now I'm going to make an easy statement here. I'm going to start talking about parallel lines first, and then we'll talk about perpendicular lines. But we're going to talk about both of them before we get into the exercise, right? Now, if I gave you guys one line, and I told you that these two lines are parallel, what do we know about these two lines exactly? What do we know about two parallel lines? What is the defining feature of two parallel lines? Anybody have any idea? How do we describe parallel lines? They're not equal, they're definitely parallel. I can tell you, Karatilo, if I decided to do this, these two lines would still be parallel. Okay, they're not equal, but they're still parallel. Okay, what do we know? Aha, that's it. Correct, Kat and Abulele. Parallel lines will never ever actually cross each other, right? They will always be the same distance apart, which means they will never cross, right? Like a track, you know, like an athletic track, you will never find those two lines actually crossing each other because they're the same distance apart, which means that the distance from here to there is going to be the same as the distance from there to there, which means the distance from there to there. Or that the distance between our two parallel lines is always going to be the same. It's called equidistant. Okay, these two lines are equidistant, which means they are the same distance apart from each other, everywhere. All right, so let's say, for instance, now I give you guys a point. Oh, sorry, a straight line. Let's make it a straight line. If I put a straight line like this, right? I know that this point over here is 0 and 2, and this point over here is -2 and 0, right? If I ask you guys to calculate for the gradient of this, can somebody calculate for the gradient of this line very quickly for me? It's a pretty easy one. Remember, we just need to label properly, right? Make this x2 and y2. Make this x1 and y1. I know that my formula for the gradient is equal to y2 minus y1 over x2 minus x1. Anybody got an answer for me? It's a pretty simple one, right? We're going to get 2 minus 0 over 0 minus -2. If we put that together, we should get 2 over 2, which is equal to 1. All right, so my gradient over here is 1. My gradient is equal to 1. Now, let's say, for instance, I want to draw a parallel line, a line parallel to the one that I've drawn on the screen. Now, if I decide that I want to draw a parallel line, right, and it goes like that, okay, we're going to say it goes straight through there, right? Now, this new point over here is 0 and 4, right? Now, my x value hasn't changed. It hasn't, right? I've just taken this thing and I've lifted it using the y value. So if this point over here had to be lifted the same, what would that coordinate over there be? Who can tell me? I know the x value isn't going to change because that one's x value didn't change. So my x value is still going to be -2. What is my y value going to be over here? Anyone? A sweet for anybody who can figure it out. It's not that difficult, I promise. Okay, if we think about how we got from 0.2 to 0.4, that's it, correct. Okay, Balissa is correct in this case, Sally, because let's think about it. Let's think about it. I went from 0.2 to 0.4. How many units up did I move? I've moved exactly 2 units up, right? So on this side, if I'm making a parallel line, I also need to move this thing 2 units up. At the moment, my y value over here is 0. So if I want to move this 2 units up, then my y value from 0 to 2 would then become 2. Okay, I just need a thumbs up. Does everybody understand what ma'am has done here? Yes? Are we understanding how that value is -2 and 2? Cool beans. All right, lovely. Now, what I want us to do is I want us to calculate the gradient of this line. Can we calculate the gradient of this line quickly? I'm going to make that x2 and y2, and I'm going to make this x1 and y1. Let's calculate for the gradient quickly. Gradient is going to equal 4y2 minus y1, so 4 minus 2 over x2, which is 0 minus -2, right, is equal to 4 minus 2 will give us 2 over 0 plus 2 is equal to 2. The gradient is also 1. So the gradient of that line is 1, and the gradient of this line is 1. Now, let me ask you guys a question. If I decided to draw another line that's parallel to both of those lines down there, right? And I decide that this point over here is 0 and -3, right? I know that I have moved from here to there. How many units did it take from me to move from there to there in the y direction? How many units? From 2 to -3, correct, Balisa. It took us 5 units. 5 units, right? So if I want to make sure that they're equidistant and I take this point and I move it down, I'm going to get the point -2. And because I've moved my y value down 5, what is the new y value for this part going to be? What is the new y value there? From 0, it will go to? Anyone see it? -5, correct, Sally, that's it. It'll be -5 this time because we moved down, -5. Now, let me ask another obvious question. If we take these two new points and we calculate the gradient, what do we think the gradient is going to come out as? The gradient will come out as correct. That's it, Kanyo. The gradient will equal 1. Right, so we can see when we are looking at parallel lines, because parallel lines are always the same distance apart, they're always the same distance apart from each other everywhere on that line. That means that the slope of every single line that is parallel to the other will be the same. They will have the same steepness, which means they will have the same gradient. So if we ever see anywhere in a paper or analytical geometry paper, if they tell us that 2 lines are parallel, that means that the gradient of the first one is equal to the gradient of the second line. All right, thumbs up. We all cool with that idea? Everyone okay? Right, that was a long explanation, but I hope it made sense. All right, because they're always the same distance apart, the slope will always be the same. Therefore, they will always have the same gradient. Okay. So I want us to have a look at a question. Let's have a look at this question over here. It says, write down the equation of each of the following lines. Right, now they're saying that the line that we want is parallel to y is equal to 2x minus 1. They're saying that it's parallel to that line and it passes through the point 1 and 8. Now, this is the equation of line 1. Now, if I have to think of line 2, what do I already know about line 2? I already know that the what, the something is something. Who has figured it out yet? If I'm looking for a line that is parallel to line 1, line 2 will have a gradient is equal to how much? It's equal to 2, correct. The gradient is equal to 2 because that one is parallel and they're both the same line. So my gradient is going to equal to 2. Now, if I want to put this together into an equation, because they want us to find the equation of each of the following lines, I'm going to use y is equal to mx plus c. Lucky for me, I already know what my m is. So this will read y is equal to 2x plus c. Now, the thing I still need to find is my c value. I still need to find my c value. But over here, they have given me an x value and a y value. So I'm going to take the x value and the y value, and I'm going to substitute them in here to find c. So where I see y, I'm going to replace it with 8. So I'm going to have 8 is equal to 2 multiplied by x, which is 1 plus c. So 8 is equal to 2 plus c. If we take the 2 over to the other side, it becomes negative 2. Therefore, c is equal to 6. So that means the equation of line 2 will be y is equal to 2x plus 6. All right. Are we all okay with how to do this? Thumbs up? We good? Can I give everybody B and C to try? Okay, lovely. I'm going to give you guys 3 minutes because we're going to run out of time and I have one more thing to talk about. All right, you've got 3 minutes to do B and C and then we'll chat. One minute left, guys. I'm suspecting it's less than 1 minute. We'll chat. All right, peeps, let's have a look at the answers here. Okay, let's look at B. All right, so they're telling us that B is parallel to y is equal, or line 1, this line 1, is parallel to y is equal to 3x plus 2, and it passes through the point 1, 1. Okay, so I already know that in order to find C, this is my x value and my y value. I already know the gradient of line 2. Because I know that they're parallel, that means the gradient of my next line is also 3. So I'm then going to go y is equal to 3x plus c, and then I'm going to use the point 1, 1 and substitute to find c. So I'm going to replace y with 1 is equal to 3 times 1 plus c. That will give me 1 is equal to 3 plus c. Take the 3 over, and that becomes negative 3. Therefore, C will equal -2. So for B, my answer should be y is equal to 3x minus 2. That's the equation of the line. All right, let's look at C. I know I'm writing everywhere, guys. I don't know what's going on. Okay, so for C, we're going to do the exact same thing. They've told us here that the two lines are parallel, so I know that they share a gradient, and they've given me an x and y value for me to find C. Right, so I'm going to go line 2. Gradient is already equal to 5, which is lovely. Y is equal to 5x plus C. And then I'm going to sub in the points x for x and y. So I'll have 9 is equal to 5 times 2 plus C. And that will give me, okay, 9 is equal to 10 plus C. And then I'll move C over, 10 over, and it'll become -10. Therefore, C will equal -1. So that tells me my equation of the new line parallel to that one, y is equal to 5x minus 1. All right, how did we do? 1, 2 out of 2, because we just did B and C. Are we all okay with that? That's easy enough. Okay, all right. Okay, let's talk about perpendicular lines, right? What do we know about perpendicular lines? We've just figured out that parallel lines need to be equidistant, and they must have the same gradient. What do we know about perpendicular lines? If I have two lines and they are perpendicular, correct, that's it, Sanili, so good. If I have one line that goes like that, and I'm going to make it black just now. One line that goes like that. And I have another line that goes like that. All right, let's say that these two lines go through the origin, okay? And they give us a 90-degree angle in the middle, because that's what perpendicular means. So they give us a 90-degree angle, just like that. Right, now this line is actually the line y is equal to x. Okay, I've just made that up. Okay, because it goes through the origin, I'm going to say that this point over here goes to the point 1, 1, and the origin, which is 0, 0. Right, now on this side, because these two lines are perpendicular, this point goes through 0, 0, or this line goes through 0, 0, and on this side, it goes through -1 and 1. Okay, so if we calculate the gradient of these two lines, right, I'm going to name this x2 and y2. I'm also going to name this one x2 and y2, and there's a big reason for that. And 0 is going to be x1 and y1. Now, both of these points go through the origin, right? They both go through the origin, so they're both going to use x1 and y1. So let's name this line 1, and we're going to name this line 2. Now, if we find the gradient of each of these lines, I'm going to find the gradient of line 1. I'm going to get 1 minus 0 over 1 minus 0, and that tells me that my gradient over here is 1. So the gradient for this line, m is equal to 1. Now, if I find the gradient of line 2, I'm going to get y2, which is 1, minus 0 over x2, which is -1, minus 0. And that's going to give me 1 divided by -1 will give us -1. So if we look at these two gradients, we can see that one is positive and the other is negative. And it makes sense because we can see that this one has a slope, it's sloping downwards, so my gradient must be negative, and this one is sloping upwards, so my gradient must be positive. Okay, but I'm going to stop here